Okay, so in this first section, we're going to explore briefly the geometry of 3D shapes. Now, over here, we're going to start by introducing the midpoint and distance formula in space in 3D. So if I'm given 2 points A and B with their given coordinates, now as you can see in 3D, each point has a third coordinate, which is called the elevation, because in fact in 2D the plane you're familiar with, which is X and Y plane, in 3D it would in fact, you would in fact visualize it as horizontal, and the Z-axis would in fact be the elevation of the objects or the points in space. Okay, so in fact the third coordinate would in fact indicate by how much the point is being elevated from the XY plane. So as you can see, the midpoint formula here, if we introduce I, the midpoint of segment AB. Now the midpoint formula in 3D is no different than the one you're familiar with in 2D. The coordinates of I would in fact consist of averaging the coordinates of A and B. So x of A plus x of B over 2, y of A plus y of B over 2, and it's the same thing for the elevation. And similarly, regarding the distance formula, notice that the distance between A and B would in fact be the square root of the sum of the squares of the difference between the coordinates of A and B. So it's xa minus xb all squared plus ya minus yb all squared, etc. Similarly for the elevation. So if we were to put this into a quick example here. Now we have here a cuboid in this example. Now, usually a cuboid would in fact refer to a rectangular prism, where in fact you'd have the sides of the cuboid being rectangles. Okay, so over here we have the cuboid OABCDFG, over which we have introduced an orthonormal system where O is at the origin of the system, and we have here distances OA, OC, and OD being equals to 3, 4, and 2. You can see as indicated on the figure. Now over here the axes are in fact indicated by the given. We have that A lies on the x-axis, so this is the x-axis. C lies on the y-axis, so this is the y-axis, and D lies on the z-axis. Okay, so over here we're going to first start by writing down the coordinates of the points A, B, E, and F. So, of course, O being the origin of the system, O would in fact have the coordinates 0, 0, 0 being the origin of the system. Okay, so over here we know that A lies on the x-axis, and the system being orthonormal, in fact, from O to A consists of 3 units according to the given. Consequently, A would have an abscissa of 3, and being on the x-axis, it means that y of A and z of A are zeros. Now, over here, we're going to do C first in order to, even though the question only asks for A, B, E, and F, I'm just going to find the coordinates of all the points on the figure. Okay, so over here, having point C is on the y-axis, and we know that it's 4 units away from O. So in fact, point C has an x equals to 0, a y equals to 4 because it lies on the y-axis, and a z equals to 0. And similarly for point D lies on the z-axis, so its x and y coordinates are zeros. And being 2 units away from O, it would in fact have an elevation of 2. Now, over here, let's just go to point B. Now, point B lies in the same plane as A, O, and C. So point B, in fact, lies in the plane X, O, Y. So point B being in the plane XOY has a z equals to 0. Okay? Now, as you can see, this being a rectangle at the bottom. Okay, so this being a rectangle, it means that B is in fact 4 units away from point A and 3 units away from point C, which means that over here, B and A have the same abscissa. So over here, the abscissa of B is 3. So since we have a right angle here, the edge AB is in fact parallel to the y-axis, therefore x of B and x of A are equal. Similarly, edge CB is parallel to the x-axis, therefore y of B and y of C are equal. So over here we have the abscissa of B is equals to 4, since of course we have a right angle here. Okay, now next we have point E. Where's point E? This is point E. Now point E, now over here E and A, segment EA is in fact parallel to the z-axis. So E and A have the same abscissa, they have the same x value. So E has an x the same as x of A, which is 3 units. While since EA is parallel to the z-axis, it has no y coordinates. It never left the region of the x-axis, so the y coordinate is 0, and E has the same height as D, therefore the elevation of point E is in fact 2 units. Now as for point F, over here, we have that F has the same height as D, right? This being a cuboid, all sides are rectangles. So F has the same height of D, therefore F has an elevation of 2. Similarly, F is further away from the x-axis as B, so therefore y of F is in fact the same as y of C, which is 4, and F is also further away from the y-axis as C, or G in fact, so F has an abscissa of 3. You can see it as well since EF is in fact parallel to the plane ZOY. So in fact, EF would have the same abscissa as A. Now, lastly, I think I still have point G here. So regarding point G lies in the plane YOZ, therefore x of G is 0. Now, similarly to how we found the remaining coordinates, now CG is parallel to OD. It means that y of G and y of C are the same. G and C are 4 units away from the z-axis, which gives a y equals to 4. And G has the same height as D, consequently having an elevation of 2. So these are the coordinates of all the points you have here on the figure. Okay, so it requires a lot of perception and in order to visualize things in space, in order to be able to determine the right coordinates. So this really needs a lot of practice. Now in part 2, we need to determine the coordinates of the midpoint of OF. Now we no longer need the figure because now we have all the coordinates of all the points on the figure, so we could just apply the midpoint formula. So I would, in fact, the coordinates of the midpoint, okay, so I'm gonna call it I. So the coordinates of I, the midpoint of OF. So OF, O has in fact all its coordinates equals to 0. So it's just coordinates of f over 2, because it would be more like 0 plus 3 over 2, 0 plus 4 over 2, and 0 plus 2 over 2, which leaves me with I having as coordinates 3 over 2, or 1.5, 2, and 1. And similarly, if I were to determine distance OF using the distance formula, that would be the square root of 0 minus 3 all squared plus 0 minus 4 all squared plus 0 minus 2 all squared, which leaves me with the square root of 9 plus 16 plus 4, which is the square root of 29. So, in fact, that's the square root of 29 units. That's the exact value of the distance.